So good morning. Actually, before I begin, I want to thank Mike Dean. I served with on the 2009 Newsweek. And so I'm John Callahan. I go by Jack. I work at the Johns Hopkins University Applied Physics Laboratory. Currently on IPA to the Office of Naval Research. And actually I'm in London. That's a long story, but I'm actually here while the wedding is going on. But Mike, I have a gift for you that I brought, which is a tea towel, which is a very popular gift here. And I think your wife said she's quite a royalist, so she should really enjoy this, right? There you go.
Thank you very much.
So share the last night. This is a project that I've been trying to push out the door that we did at APL, and it's called Aqueduct. It is connected with Semantic Media Wiki, and hopefully you'll see. I think because the machine is back there, I won't really do a demo, but I'll just talk about this because it's really kind of interactive. But we do have a Semantic Media Wiki driver that's built into this. The essential problem that we were trying to solve was we were big fans of Semantic Web, and we wanted to use a Semantic Wiki. However, the data sets we have and we needed to get access to were not A, owned by us, B, were enormously large, okay, hence the name Aqueduct, big body of water and sort of a tiny pool. So, and the option of ETLing, so essentially taking the thing, serializing it, kind of like what Jim Hemler's done with the data.gov stuff, I think, on his website, right? They've externalized all the data.gov stuff and put it up on their wiki, right? And they scrape and put it up periodically. We said, well, wait a minute, hang on. Let's look at this a different way. Keep the linked data site where it is, but essentially project it, okay? Or have a projection locally. So I teased Mark Reeves with this back in Amsterdam, right? But actually, it's now been pre-pubbed and given permission to be open source. So the bottom line is actually absolutely, yeah. Cool. So we actually have a Google Code site, but there's no file release yet, but it's going to be there. We just have to actually get a budget for actually putting it up. That's the only impediment right now is actually that. So seriously. So in the last year, we've jumped through all the hurdles. But the essential motivation was how can you allow the linked data sites to live where they live, be where they are, change, and essentially on demand have wiki articles tied to them that's pulling the data, optionally caching it locally, so you don't have to always fetch back to it, right? So that's sort of configured per data source. So that's what Aqueduct is, and the metaphor is lots, this enormous lake, and then you have this little pool. But in fact, what I'll say, the little pool itself, each wiki article, now itself becomes a linked data endpoint. So each wiki article, we extended the MediaWiki API, which actually has an API.php, to actually give you the JSON results of the article. So the projection of the source, you can do things like annotate it, add new triples that are your commentary on the backend record. In addition, well, actually, I'll get to some of this. So that was the motivation. Now, the problem that came to us, let me motivate this with a concrete problem. So the problem that came to us, I was sitting there one day and I said, oh, why don't you come to this meeting? There's a guy, MIT Lincoln Labs, he's down in Haiti at the U.S. Embassy right after the earthquake. They need help. They got all these NGOs, they're trying to coordinate, they've got all their different data sources, they need to make sense of it. Well, I sat in the back of the room and was like, well, this stuff wasn't ready. And I've been beating the wiki drum so much that if I put up my hand and said, let's use Aqueduct, I'd seem like the guy with the hammer. Okay, so I just sat quiet. And after a week, it was clear that there was a vendor they had in mind, and they were mostly focused on data collection. They literally had these electronic tablets they were going to go around. The UN OCHA, Office of Coordination for Humanitarian Affairs, was already on the ground doing a paper-based thing and then putting it into Excel. And they've done this before. They have a process called IRA reports. Well, we had actually had access to all the IRA reports, the Initial Rapid Assessment reports. So after a week of just holding my tongue, I said, hey, wait a minute, what's stopping me from using this data to explore the problem at least. And if something happens, I'll raise my hand at a meeting. And actually that did happen. There were some good outcomes. They did not use this because they went with a vendor and they did traditional database integration. And, you know, with lots of work, just threw all the data in and had digital libraries doing it. So because they needed something right away. But I persisted to use this as the target problem. And it's been a fairly rich one. And in fact, it's attracting some attention now, even in O&R. Because if you didn't know it, the U.S. Navy has a lot of things to do in humanitarian assistance and disaster relief. No surprise. So at these meetings, there was this. The JTF Haiti essentially said, this was the general in charge. I'm not sure if he's still there. So this was his program, literally, saying, here's what I want you all doing every day. He had a bunch of analysts essentially down there. They were getting input from the government of Haiti, that's GOH, NGOs, military, and so forth. So basically do this loop. For each IDP, that's internally displaced person location, okay, assess the food, that's water, sanitation, and health, shelter, and medical. For each step from today into the future, compare the supplies provided to that needed, and then the military fills that in, and repeat until the military is not needed anymore. Okay? So they have to prioritize the IDPs and what they need, okay, and then go get stuff to them. That's basically the daily operation loop. The problem with this, so this is a dashboard that was desired, never built. This is an eye chart, so don't worry about it. But essentially there was disagreement from the different analysts. So here's a case in point. These IDPs are really important because medical is important. So no, food is important. So actually disagreements between these different analysts. Okay. So not only is the data from lots of different sources and dirty. Oh, and by the way, the IRA, all the properties are in French. Okay. Yeah, seriously, the format survey that are in French. But now you have the analysts disagreeing on what. And one case in point was one analyst raised his hand and said, the rainy season is coming and all those IDPs on the hills, they're going to wash away with the mud. Oh, that changed their assessment, right? So we posited, well, why not use a wiki to coordinate these opinions, give the general access like a dashboard, but the important thing is, so dashboards are great. People love, these big, I like to see what's going on. But if you drill down on any particular map, you can't, right? But what if that particular map led to an article where that data was coming from with that analyst's opinion? And then they could drill down to that, to actually the raw data report. So actually, for example, each record coming from the IRA database, so I'll pick on the IRA database in this slide. We actually have a wiki article for each IRA report. It's very raw and very done. And you almost would never go to that article. And in fact, they're fetched on demand from the back end. Okay, so the article isn't produced. Okay, it doesn't sit in the wiki until it's reached, until it's hit. Okay, just like a wiki, the article doesn't exist until you actually hit it for the first time. But you can actually compose articles. We actually extended the page inclusion mechanism to include data inclusion. So what happens is the triples in one article can be included in it through the inclusion mechanism on other articles. And this way you can make up dashboards. And then in fact lead to drill down. So you can say, well, why does that particular, so going back to the dashboard here, oh, why does that say that? Or why is their opinion that? Okay, and if you want to, drill down. So that's the concept architecturally here. So here, for example, is a type of analysis this analysis discovered. So an analyst would use the wiki article to express his or her opinion. And this is just a fake article, but this is a Google map. So this is a particular widget. We have a set of widgets. These are not the MediaWiki widgets. We have our own widgets, and there's a reason for that. Primarily, when you go to a page, these widgets sit on the page, but they're not produced with the page rendering. Actually, the article renders, and then there's a second cycle, it's a jQuery-based system, that goes back to the API.php for the article, and then pulls all the triples in JSON format and populates all the widgets on the page. This is efficient because I'll show you that the first way we did this 3 years ago is we fetched the triples per widget, and if you have 10 widgets that are accessing the same data, that's really bad. So the page itself holds the triples, okay, in the JSON in the background in JavaScript, and then all the widgets have access to it. Okay. So there's a map widget showing, and they're sensitive to the particular RDF properties, right? So this one will show the WGS 84s, and this is just even the template tabular form and so forth. So the case in point is an analyst might try to make a case saying, here's why I think these IDPs are important. And the data is sitting with the page. So not only is their opinion, their analytic opinion here, but also the fact that data is on the page. So this kind of ties analytic opinion with the data supporting that. I think that's one of the findings of this particular exercise. So this idea of building up in Wiki and composition from raw reports and raw, I'll show you one of these articles. Actually, I think it's next. I mean, it's something you would never drill down to, but you can use that in other articles, right? And if somebody actually wanted to go to that data, they could. So here is what we call projection. Articles are created on demand. They essentially reach back, get the triples, and then the article is rendered. And you have a caching option. I'll show you the configuration page. You can do this with different data sources. So in fact, each data source is configured through a special page in MediaWiki where it's associated with a namespace, right? So you give the namespace, and there's essentially a bunch of parameters. So it's namespace driven. So here's a raw report. This is actually one of the IRA reports. You see the properties are in French. We just did a dumb, take the raw report. They're not in RDF, but we took them all. And so here are all the French properties. We just invented its own namespace. We didn't try to normalize anything. So okay, here's the IRA reports. They all have URI, IRA, S1 V10, because the reports have version numbers and there's sections. So this is section 1, version 10 of the IRA assessment tool. And then here are, description de la population, nom du underscore B. Anyway, so we just transcribed all these. Now, the next problem was this. Well, Jack, this is neat, but the data contains errors. So here, for example, is a misspelling of that particular community, Croix-de-Bouquet. I pronounce my Creole French, okay? And it turns out, for some weird reason, the surveyors don't put their full name. They put the name, and then some of them postfix it with like the ID number of the survey report. I guess they were told by some manager, this stuff happens, right? This is goofy. So there's lots of dirty data. They didn't follow for it. It's just terribly messy. So I got this complaint. Well, Jack, you have to, the scrubbing bubbles. Put it through the ETL factory and scrub it clean, and then it goes into your database. Well, I sat about this, and tossed and turned at night, and I said, no. Let's load it in, messy and all, and so inspired by linked data, right, and Halevi's data spaces work, let the wiki do the work. Let crowdsourcing do the work in cleaning it up. So here, for example, is that particular record. So this is the wiki article for that record, Haiti R01002 record, right? This one individual report that you saw. This is just the widget, AQ raw widget, that displayed that stupid table of just all the exhaustive products. That's a default widget, Aqueduct raw widget. But you can actually put triples in the article. That will override the option for names that you can override or add to. But these override those properties. So what I did in this case was actually not only corrected the name of that community, but linked it to the DBpedia page for that community. Turns out there's a DBpedia page for Croix-de-Bouquet. And I also corrected her name. Now, it did not correct it to the back-end data store. That's read-only. Although we made an improvement, and Jeff Stuckman is here. He's the primary programmer at APL for this. He'll make some comments later. To actually, if your data store is writable, that there's a pass-through that it can't change, okay? But in many cases, it's just read-only. So this is essentially now a new record at this wiki that's hittable as an API.php for new triples. But it's essentially layering a comment on it, right? So it's just sort of reversioning that. So the result of this is a new article in which I now have a hyperlink to another article, which actually also pulls from DBpedia into this particular wiki. So I created another namespace in this particular wiki that uses Aqueduct to pull that in. So it doesn't go directly to DBpedia. And then there's her link to actually her article as a surveyor, right? So I've improved the data somewhat.
So where do you store the data locally? Like you add it in the wiki? Is that in some triple store or is it?
No, it's actually on the article, so it was right there.
Oh.
There it is, right?
So
That's where it's stored.
In the markup.
Yeah, it's in the markup. So yeah.
Have you had, how have you dealt with issues of performance when you're trying to go out and grab?
Well, okay, so I don't know if I have the, in those cases, for example, where you have a really slow backing store, you want to cache some of those. So you're going to have issues of consistency. Yeah, but I bring up, fine, let's invoke some of the eventual consistency literature, right, and say, it's more important that I actually have that rather than waiting a cycle and putting a cache timeout on it. So yeah, certainly. So as soon as you say, I'm going to pull, each time, you run into the performance problem, right? Or we can get around some of that by caching. So, but there's room for improvement. You can also, we have namespaces where you actually do embedded and do the typical scrape and load it in. And we also have a Semantic Media Wiki driver that's nascent right now, where you can put it into a namespace that uses Semantic Media Wiki and use those triples as a source. Also, we actually go back in and out through the local host API. We don't access it internally. Okay, so.
You also noticed that Jack had mentioned that the widgets are all loaded asynchronously. So if there's one very slow data source and it's just not loading, all the other content on the page appears and is usable. And you'll just see like a loading indicator for the slow data.
Yeah, it's asynchronously loaded, so you don't wait for the whole article. The widget's just sitting there going, waiting for the backing store, waiting for the backing store. So you can still read the article and so forth. Right? So the other thing is with widgets. So as I said, our previous incarnation of this, we had each widget go out, and the problem is 10 widgets on the page wanted the same data. So we changed this to essentially the page has all the data, and the widgets all have access to the same source. It's all just in JSON RDF. Composition. Oh, so this talks about the concept of not only composing the data into articles through the data inclusion extensions, but also you can include widgets from articles. So you can actually have an article include the other articles and bring the widgets and the data along with it for a dashboard. So we call this composition. So you're composing articles, right? Not the projection of the backend, it's composition. And we were working toward this. We never got to this, but this was sort of our goal to say, give the general a dashboard, but a drill-down dashboard based on real data, right? And not just a mission operations center sort of thing, but something that's supported and drilled down. So that's kind of what we're going to. So that's a summary. There's an ozone aspect to this. I just want to know for those of you who may be aware of ozone. Okay, so there's an ozone aspect to this. And here's the team. So myself leading this, Jeff Stuckman is here, and there's a group at APL that's still using this on various products and projects. So I guess I'll end here. We have a little demo, but it's hard to get back there. Is there anything else I want to talk about? So I didn't talk about the Semantic Media Wiki driver. I have a demo of that, but maybe later offline. Maybe y'all can see it. Any questions? No questions? Yeah.
You said you're going to open source it on Google.
Yes,
Do you have a timeline for that?
Let me see it. Do I have a...
When do you expect to do that?
Get out of this. Oh, there we go. I do not know. I don't know the timeline on that because it's sort of money dependent right now. I'm paying budget. It took a year to get it through approvals and so forth.
Just put it up.
Jeff, any guesses?
It seems like it could be done relatively soon.
Well,
if we just put it out.
So, Jeff, do you want to say anything about things that have happened between last May, when this presentation was really kind of done, and now?
Yeah, so with Aqueduct, I know that something that some people have talked about with Semantic Media Wiki is the fact that you want the data to live external to the wiki and just sort of dynamically bring external data in whenever the user's loading the page. And that could also help you with security and things like that if the security was handled by the underlying triple store. So what Jack just presented was taking data that lives outside the wiki and bringing it basically to the user through MediaWiki. Now what we've done since Jack made his presentation is that now we can go in the other direction and we can actually have editable widgets. So say that you have some, I'm not sure what this is, but say you want to edit the population of the Jersey Island. With some of the widgets that we've developed now, you could actually click on that number, edit it, hit save, and then if the external triple store allows you to do it, and if your authentication with the external triple store allows you to do it, it would actually find where that data originally was loaded from and persist that data back to the external triple store through the same method that it uses to load it. So it's sort of more of a read-write thing than a read-only thing now. Also,
Go ahead, Jeff.
I was going to mention something else.
Sure.
If you're going to say.
Go ahead.
Another thing that we've done since this presentation was made is we've added an enhanced ability to have multiple widgets on the page communicating with each other, and more ability for the widgets that display to depend on context. So, for example, up here, I could have a box where I'm listing all the islands that I'm working on, or all the islands where my friends live. So when I hit the save button over here, when I saved the page and reloaded it, I could make a list of the populations of all the islands that I care about. I could make that list display on the bottom of the screen. And the way that I do that is the page would basically have two queries. The first query reads and writes my list of friends and where they live. And the second query is a Sparkle query that takes that, joins it on the population list, and then displays the populations. So in that way, you can have a whole collection of widgets on the screen, all of them displaying the data that you need to display, in some cases even from different data stores.
I was going to briefly show the Semantic Media Wiki. So here, for example, there's just two islands. This is kind of a composition page. There are two articles, Island Jersey and Island Maui. They have Semantic Media Wiki properties on them. I can go to one of them, so Island Jersey here. And here's this population triple. You edit the source, you can see it here. So it's just a standard property there. Oh, you saw the delay in the widget there loading. So actually that's an ask query, but it's also co-resident with, you can lay out arbitrary HTML and actually templatize it. You can use the templates or actually have it right there on the page to go through the records and display what you like in an article. And these add data, that actually says you can specifically say, I want to add the data. That's the data inclusion mechanism. That's like doing an inclusion of an article itself. This just adds the data. I want to add all the triples from those two articles into this one. The raw widget at the top displays on the ask widget. That just shows you can put these things on the same article. That we made Semantic Media Wiki they work together, but they're not dependent. Okay, so you don't need Semantic Media Wiki to run Aqueduct, but they don't step on each other's toes. So we want to make sure.
Yeah. So just to clarify what it is, Aqueduct is an independent piece of software from Semantic Media Wiki. Aqueduct allows you to take data from external data sources and then use the widgets to view and edit that data. And you can actually consider your own wiki, in a sense, to be an external data source. And that way use Aqueduct widgets to visualize and edit Semantic Media Wiki data in your own wiki. And we haven't tried it yet, but I could see how you could do that for external wikis as well and get some federated data loading into your main wiki.
So here's Firebug. The cycle of the page load is the page is rendered and then the page reaches back and there's the actual call, api.php with action Aqueduct, and that's where the triples So the back end, so there's a 2-cycle for this article, right? The actual content, and then there's a 2nd cycle to bring the data itself. And here's the JSON triples that come back for that, and the widgets access that information on the page. You saw that briefly. There was a little cycle thing that was the widgets waiting for the data.
So I think now you might be able to see that Semantic MediaWiki is really tailored for the use case where you want to have all your data stored in the wiki. And in some use cases that's preferable because you want to have it all in one place and make sure that the data doesn't get separated from the articles, or you want the data to be described in line with the article text itself. However, for the use cases where you want the data to actually live externally, that's the use case that we tailored Aqueduct for.
The other data set, for example, is Ushahidi, so access to the Ushahidi records. If you're familiar with the alert records there, but that was another source. And the idea is to perform this integration, but not have to work at all the alignment. So, there's no question? Yeah, go ahead.
Well, actually, so what if the data source is down? What do you do?
Well, then you're screwed. Okay. Or if it's cached, right? So behind this, I'm running a Redis server that actually. So you can either use Memcache or Redis, and there's Redis running here. So I think I could shut down the network, and I can still get the triples right from DBpedia. I won't get Google Maps on the articles, right? Okay. So yeah, I mean you're subject to the whims of those back-end data sources, but this is your playground, sandbox, and your good question. Yeah.
I didn't catch it. Maybe you explain it. What's the mechanism by which it gets the data?
Okay. That's each. So, for example, we have about 6 different drivers. The extension allows you to plug in drivers. So there's an ARC2 driver. There's a, oh my goodness, what are all the drivers? There's an embedded driver, so if you actually just have triples on the page itself, there's
So the drivers are really for external triple stores.
Yeah.
For whatever external triple store, you can write a driver for it. And we also have a driver for like a REST service that returns, or just downloading RDF off of web pages. So if you had a collection of web pages with RDF, you use that driver and you can visualize that RDF in the wiki.
So there's a project called Blackbook, and I use the SOAP-based driver. There's Semantic MediaWiki does. Oh, there's a REST interface now? Yeah. So it depends on that back-end source you have a driver for it.
So basically, once you retrieve the data from external sources, at RDF, then they will just save the RDF as the annotations on the page, right? Semantic annotation on the page, or they just keep it as RDF.
It depends on your application.
We've never stored them that they're fetched and then put in the article and persisted in the article itself.
Well, that was your example.
You can make annotations that essentially add or replace new triples within the article. They're essentially then added on to the fetch backend triples, or they overwrite.
So the annotation only exists as objects on the page. Then you have widgets accept that object.
And remember the article name itself, right? Maybe we didn't explain that. Again, I have to reach back there, but you see the Haiti :R1002?
These namespaces.
That actually uses that namespace. It changes the Haiti namespace into its URI, and then uses that to fetch all the properties associated with that subject in the backend triple store. So that's what it does. It uses the name title.
So there's a mapping between MediaWiki namespaces and which data store you're going to actually get the data.
Yeah.
So in that way you can access
normal
several.
practice.
Yeah. So, we didn't show a special page.
You can click on that.
Do we have time?
You have to log in first.
Oh, I have to log. That's right. Well, actually, I have one in the slideshow.
So basically, my question is, you only use the jQuery, whatever, all this JavaScript to handle or to manipulate the objects on the page, but you never really store this as semantic property inside the wiki.
So in this demo, you don't see any read-write widgets because they weren't done at the time the demo was made. But for the read-write widgets, it's saving the data back to your server.
No, it's saving data back to the
Which is sending it back to the triple store.
Right,
In another use case, you can edit the page, add some annotations, and then the annotations will be mixed in with whatever data you download and then visualized.
Right.
So it's really 2 use cases.
So Jesse, here's the special page configuration. So you see for each data source, right now we still have to give the namespace ID, so you separate these out. The wiki namespace, the URI prefix that's translated into, okay, for each object. The type, so this is where the drivers show up and pull down. Okay, what type is this backend namespace? And then there's some parameters for those types, like the location and so forth. There's sort of, name graph prefix and so forth. And then there's actually authentication. Okay, and Mark, your question about security. Here's how we handled that. And I have an anecdote. So I went to a page in Aqueduct on a particular project, okay? And I pulled up the article, and all the tables and maps were empty. And I said, is the server down? I said, Jack, you don't have the credentials for that particular backend store. So what happens is you can go to the article, but when it tries to reach it basically passes your credentials to the backend store, and then you get back the triple graph that you're allowed. And all the graphs and maps were empty. I thought the backend store was down, but actually it was enforcing access. It was kind of funny because it was doing its job, but it looked to me like it wasn't working. In any case, so that's how we handle security. So those 2 parameters have security there. And then there's a cache expires, and then you have to translate. The article always wants to start with a capital letter, but the subject on the back end might be a lowercase, right? So it's kind of goofy. And then back down here, this is we should probably get off after this. You can create namespaces that are not associated with a particular subject, but with a parameterized Sparkle query. So it actually takes the article title name, fills in the parameter on the Sparkle query, and pulls those triples back as an article.
That's nice. But the view on the triple store.
That's right, yeah. And it just looks like an article again. We did this with sort of, some people have used this, some analytic type people have used it. And they like it because they're familiar with wikis, but they never drill down to like the raw content articles, right? That's just like the mysterious black zone to them. But they're comfortable operating at the sort of wiki article level, right? But they coexist within the same system. So. But there's other power users who they love to go dive down and make their own templates and stuff like that. But you never know who those are, right? The power users versus the people who really don't want to get involved in the deep down stuff. But they can all coexist in an environment like this, which I think is an attraction for all of us who like wikis in general. Okay, with that, I'm Jeff, and I'll be here for the next 2 days. So.
This is all structured as a MediaWiki extension.
Yeah.
Yes.
Okay. Well, this isn't really a question but a comment. But let me say what I always try to say to people who develop MediaWiki extensions is, this looks awesome, but you should release it, publicize it on the mailing list, get developer accounts for MediaWiki so you can put it on the
Would you like to help?
repository.
Would you like to help?
I
We're
would
trying
like
to recruit a
to.
community. We're trying to recruit a community. It's the licensing is GPL 2.
GPL 2.
Yeah, but we had to because that's the prevailing license for extensions, right? So.
Cool.
No, I absolutely agree. All right. Thank you very much. I guess it's break time, right?
Yeah.
Okay. This is coffee break.
Yeah, coffee break. Recommended coffee break.
Can you email comparison for the
Yeah, do you have an email address?
Yes, I do.
Yeah.
He can vouch for me.
Yeah. But
Yeah,
The situational grid, the situational awareness.
yeah.
Because I'm trying to get rid of the board. I'm trying to get rid of it.
you heard my complaint.
Right. I'm agreeing with that.
This gives you
What?
dashboards
That
but
are
more.
Well, that
That
are
are usable.
That are usable. That the people on the floor can put on.
So, it has to work this way.
Yeah.
Are you going to be posting?
Sure.
When? Yeah, the high grade.
Oh, they had to go. There's actually a garage.
Are they going up
There's actually a garage.
All right. Okay. Very good. Thank you.
You're from international outreach.
I'm from University of Maryland, and also
So actually, one of the students that come down here
from Johns Hopkins University.
That's
right. That's right.
No, you're
in German.
So you'll find probably Michael's talk comes out
So you work on
and also
I know we work with
as kids talk to you too.
Be here for do you have a part?
for company communication. It's Mr. Paul Allen's company.
Aqueduct.
Hopefully in the next
I haven't yet.
Yeah, this is really cool.
That's good. Well, I'm sorry I couldn't talk much about it.
And so yeah, let's do like this. So I feel like you just keep the objects on the
Right.
on the web page level, right?
Yeah.
What do you mean by object?
Think of it like
The data you retrieve from the API.
So we have a media extension. The media wiki extension goes to your external service store, gets the data, and exposes it to the API.
There you go.
The JavaScript.
But you have to store that data in your wiki.
Not necessarily. But also, only if you want to. Yeah, not necessarily. Only if you want to.
Okay.
If you want to, you can add a cache. There you go. So when the backend data store goes down, your data's still there. But then you also have to worry about maintaining security of the cache.
So we have to increase that.
Now, if you want to contribute some data, if the user wants to contribute something, there's two ways to do it. The first way is to add it to the wiki, and it only mixed with the data in the triple store. And the second way to do it is to actually save the data in the triple store by using the widget.
I can tell you.
Right, so the MediaWiki API actually says the page data, right?
The MediaWiki API is used to access.
Page API.
It's used to access all the
all the
triples,
things on the page, on that article.
all the triples that are associated with the article.
Right, all the triples.
However, the article is associated with some triples living in the triple store. So there's like there's a mapping. This article connects to this subject in the triple store. This other article connects to another subject in the triple store.
So you actually parse the article data in the API, article title, article data, then you find where it.
Now the article title tells you where to go.